suppose we have two fixed points in the plane, say f1 and f2. These are going to be our foci. So these are our fixed points. Each one is individually called a focus. The plural of focus is foci. We want to try to describe the set of all points P in the xy plane that satisfy this property that the distance between P and f1 minus the distance between P and f2, that this distance is equal to a constant. And so I've sketched a little set of axes over here with two foci, f1 and f2. They are supposed to be equally spaced around the origin. So the origin is the center of the line segment that connects f1 and f2. And then the idea is if we make an agreement that say this point right here should be on our hyperbola, then we have that this distance from P to f1 minus this distance from P to f2, that this difference should be a constant. And as we try to trace out all the points that obey this property, we see that this shape that's traced out forms what's called a hyperbola in the plane. And so the idea here, again, is that maybe this point up here, if we call it Q, this obeys the same rules. The length of Q to F1 minus the length or the distance from Q to F2. That difference is a constant, and not only is it a constant, it's the same constant that we have for the other difference over here. Okay, and so this is one arm of a hyperbola. It turns out that this situation is symmetric, and so this entire curve can be flipped over. And, oops. On the other side, it traces off a mirror image of the same shape on this side. So the green curve here is supposed to be a mirror image. I didn't draw it correctly, but that's supposed to be a mirror image. And on this side, this whole thing traces out. It's got two sides. This entire graph, both sides included, is called a hyperbola. Okay? Now, in the next lecture video, we are going to talk about the different properties of the foci and some other things. But in general, a hyperbola is given by an equation that looks like the following. So x squared over a squared, the way I've drawn it here, it's going to be x squared over a squared minus y squared over b squared equals 1. And this is true for some constants a and b. And so this will give us a hyperbola in the orientation that I've drawn here. If you reverse this situation, then you'll end up with y squared over b squared minus x squared over a squared equals 1. This changes the hyperbola. It's still a hyperbola, but it changes the orientation so that the hyperbola, the two halves of the hyperbola are arranged vertically in the y direction.